Is Earth possibly the only civilization in the universe? Before addressing this hypothesis, let's review a classic theory. If extraterrestrial civilizations exist, where are they? If we can't find them, why would we assume they exist? This is known as the Fermi Paradox. Let's take a look at the history of human technology. Around 200 years ago, humans were still debating heliocentrism and geocentrism, and those with opposing views could face persecution. This suggests that human technological civilization is only about 200 years old, considering Earth's development over approximately 4.6 billion years and the universe's existence for over billions of years. Human technology has rapidly progressed within just 200 years to achieve moon landings and space exploration. If we conservatively assume the development of this technological civilization to span a billion years, we can hardly fathom its potential advancements. If there are indeed extraterrestrial civilizations, their technological levels would likely not coincide with Earth's at the same time. This time difference could be anywhere from thousands to billions of years. So, why haven't we detected Earth's presence with billions of years worth of advanced technology? And why is there no trace of extraterrestrial civilizations to this day? Could it be that we truly are the first civilization in the universe? It's worth considering this hypothesis. Earth's uniqueness is apparent when we look at its characteristics. Its magnetic field, for instance, is crucial. Earth's magnetic field is sustained by its iron-nickel core in a molten state, providing a protective shield for life to thrive. However, creating a stable magnetic field that lasts for billions of years requires more than these conditions. This is where Earth's massive satellite, the Moon, comes into play. The Moon's origins are subject to various theories such as capture, co-formation, and impact. Earth-specific circumstances, influenced by the Moon's tidal effects, have resulted in an inconsistent rotation of its solid crust and mantle compared to its liquid core, giving rise to the magnetic field. Earth's strong planetary magnetic field has shielded life from deadly particle storms, a key factor in the stable evolution of life. The emergence of large biomolecules isn't difficult. The challenge lies in the step from non-life to life. All known life on Earth shares a common feature: a lipid membrane. The emergence of this lipid membrane structure provided a stable internal environment necessary for life to develop. In primitive oceans, lipid membranes floated on the water's surface and formed lipid bubbles under specific conditions. These lipid bubbles, with a small chance of containing essential biomolecules, became the rudimentary forms of life. This process likely occurred along coastlines due to the lipid membrane's floating nature, which points to the crucial role of tides. From these perspectives, a massive satellite like the Moon acts as a vast reservoir of energy, providing a stable environment with predictable variations on the planet's surface. While there are many star systems similar to our solar system in the universe, rocky planets like Earth with a large satellite are rarer. Thus, Earth could be likened to a fortunate anomaly in the cosmos. Let's talk about the probability of life emerging in the universe after discussing the coincidences of Earth. From a temporal perspective, the universe hasn't allotted much time for the birth of life. At the beginning of the Big Bang, the universe contained only 3 elements: hydrogen, helium, and lithium. Other elements formed later through nuclear fusion reactions within stars. Judging from the abundance of elements within the solar system, the Sun is definitely not a first-generation star. It's highly likely not even a second-generation star, but rather a third-generation, fourth-generation, or even later. The earliest first-generation stars turned into compact stars, black holes, or even quark stars. The surface hydrogen shell was expelled through nova explosions, and a portion of the core's dispersed material formed nebulae, gradually coalescing to give rise to second-generation stars. This means that only through the continuous cycle of stellar death and birth could a star system like the solar system emerge, and after several cycles of death and birth, stars could have rocky planets. From a temporal perspective, although the universe is approximately 14 billion years old, it takes hundreds of millions of years for the birth of star systems, the formation of rocky planets, their cooling, the emergence of life, and the development of intelligence. Therefore, When assessing the time for the emergence of life, we cannot simply start from the beginning of the universe's Big Bang. We must consider Earth's age as the starting point. So, do you think that other planets have ample time for life to develop? While we might not be the only life forms in the universe, is it possible that we are the only civilization with technology? However, the existence of star systems like the solar system isn't sufficient. To give birth to life, a critical factor is having suitable stars. If a star is unstable, it's useless. The nearest star to the solar system, Proxima Centauri, frequently emits strong flares, an environment where life wouldn't thrive. Very large stars are also unstable, and even stars similar in size to the Sun are not always stable. There's a considerable number of medium-sized stars that frequently emit major solar flares, making them unsuitable for supporting life. Additionally, planets need to be at an appropriate distance from their stars and have axial tilt. These factors aren't randomly generated. They require the precise impact of small asteroids. Furthermore, the moon's gravity must influence the flow of the planet's core, generating a magnetic field. The moon can't be too large or too small. It must be just right. The probability of these conditions occurring is extremely low. Even the Earth's rotation speed after an impact can't be too fast or too slow. It must occur at just the right time for life to develop. Advanced intelligent life on Earth took at least 4 billion years to evolve. If the impact occurred too late, there wouldn't be enough time left for life development, as the sun's temperature stabilizes and its heating phase lasts only a little over 5 billion years. After exhausting its internal elements, nuclear fusion would push outward, causing temperatures to skyrocket, rendering Earth inhospitable for life. All of this is incredibly coincidental and difficult to replicate. It's uncertain whether tens of thousands, millions, or even hundreds of millions of galaxies and their planets would have a chance like this. So, is the probability of extraterrestrial civilizations existing high? Not really. The Fermi Paradox has raised many questions, and people have been trying to answer it. Various hypotheses have been proposed to explain the Fermi Paradox. There are roughly 3 possibilities. The first is that extraterrestrial civilizations truly do not exist. The second is that extraterrestrial civilizations exist, but we are unaware of each other. The third is that extraterrestrial civilizations exist, they're aware of us, but we're not aware of them. The non-existence of extraterrestrial civilizations can be divided into 2 possibilities. The first is the uniqueness hypothesis, where humanity is the first and only civilization in the universe. The second is the extinction hypothesis, where conditions in the universe only recently became suitable for the development of civilizations, and prior civilizations may have existed but were all wiped out. The scenario where there are extraterrestrial civilizations, but we are unaware of each other, can be divided into 3 possibilities. The Great Filter hypothesis, where civilizations cannot overcome technological barriers due to vast distances or undiscovered cosmic laws. The Island hypothesis, where civilizations are so distant that contact is impossible. And the Dark Forest hypothesis, where civilizations intentionally hide to observe others. The scenario where there are extraterrestrial civilizations, and they're aware of us, can be divided into 4 hypothetical possibilities. The ant hypothesis, where they ignore us like we ignore ants. The zoo hypothesis, where they observe us without interfering. The censorship hypothesis, where they use a censoring field to hide Earth. And the simulation hypothesis, where our reality is constructed by their shared consciousness. Putting aside these diverse theories and explanations, it's also possible that there are no extraterrestrial civilizations in this universe. This would mean we can't find any trace of their existence, which could be either a comforting or concerning thought. If we are indeed the only civilization in the universe, it could be scary because our current technology isn't invulnerable. Natural disasters like asteroid impacts or supervolcano eruptions could potentially wipe us out. If something goes wrong, the one shining life in the universe would cease, leaving silence for billions of years before life could potentially arise again. Considering all of this, after reading through these thoughts, do you agree that the birth of Earth is a highly improbable event within the entire universe? And if you agree, do you still believe in the existence of extraterrestrial civilizations? Let's discuss this in the comments section together.